Welcome back, everyone. So it's back by feedback of uh, one of the people that watch our videos. So we made it one screen only, and only a small uh, capture of me in the background because they think it's distracting. So in this video, we will discuss a very important part of human to computer interaction, which is interfaces. So there's a lot of topics with regards to human to computer interaction, but I only try to teach the things that I think will be useful in the future. The timeless, uh, timeless concepts that will help us moving forward. So let's start. This topic is about interfaces. We have four types of interfaces: command-based interfaces. Second is graphical or visual interfaces. And third is physical or sensory interfaces. And then fourth is multimodal emerging interfaces. So um, For multimodal and emerging interfaces, those are combinations of a lot of interface. So a lot of interface that's in the and the GUI and physical interface are also in this bracket. Let's see, tangible, shareable. Actually, none of physical interfaces are here, but actually there is, there could be a physical interface here. It really depends on people's creativity, but we will discuss that moving forward. First is the command line interface, which was invented in 1970. This involved explicit instructions given through language, symbols, or precise input like spoken, typing, drone, or thought. Um, the first type is a command uh, line interface, such as this. This is an example of a Linux interface. It's in Mac OS. You can also see it in Windows in command line interface. Basically, it's about interacting via commands or type language. First, early interactive interface required the user to type in commands that were typically abbreviation, for example, LS, and the prompt symbol appearing on the computer display, to which the system responded. So this LS it provides all the files available on the directory. Second, some commands are also a fixed part. So this is an example of that. Here's the ls, and then it shows all the directory. The desktop documents, download, Dropbox, library. Some commands are also a fixed part of keyboard, such as delete, enter, and escape, while other functions keys can be programmed by the user as specific commands. For instance, F11, commanding print action. So if ever someone plays Dota, the hotkeys is how you can program a specific commands. So it's the same here with command line interface. So it used to be just typing or communicating to the computer via text. The most relevant design principle is consistency. Therefore, the method used for labeling or naming the commands should be chosen to be as consistent as possible. For example, always use the first letters of the operation when using abbreviations. So, for this interface, for example, this LS, it starts with the first letter of the command. For example, you basically like you need to make it consistent. You need to make it as natural as possible and avoid the user. having to think what command is that. It needs to be distinguished with the command with other commands available on that command line interface. We will discuss this further. Second form of command uh, interface is voice. A voice interface involves a person talking with a spoken language app such as search engine, a train timetable, a travel planner, or a chatbot. Voice interfaces use an interaction type of command or conversation where a person speaks and listens rather than clicks, touches, or points. The first generation of speech system earned the reputation mishearing all too often what a person said. So the first speech recognition or speech interface is a failure. Like this, it says recognize a speech, but it says recognize speech. So that is important because a lot of people think that this technology is matured enough that it can mimic a person speaking, but it's actually not, as we will see later. Speech to text systems such as Otter and Dragon enable people to dictate rather than have to type, whether it's entering data into a spreadsheet using a search engine or writing a document. The words spoken appear on the screen. For some people, this mode of interaction is more efficient, especially when they are on the move. Dragon claims on its website that it's three times faster than typing and it's 99% accurate. So a lot of people, they don't have time. So this Dragon app, it allows the people to speak their thoughts and then it will automatically convert it to text. And based on research, it has a 99% accuracy, which is great. So this type of task has advanced dramatically. An increasingly widespread application of speech technology is call routing, where companies use an automated speech system to enable callers to reach one of their services during a phone call. They voice their needs in their own words, for example, I'm having problems with my Wi-Fi router, and in response are automatically forwarded to the appropriate service. This is useful for companies as it can reduce operating costs. It can also increase revenue by reducing the number of lost calls. So this technology reduce the operating cost. So what used to be an operator that will human operator that will transfer you to other right department that requires them to learn a lot of knowledge. Now it has been automated by this speech technology. Despite big advantage, so here's what I'm saying in speech recognition, conversational interaction is limited mainly to answering questions and responding to requests. So remember the principle of the conversation, making statement, asking question, and giving replies. So these both are limited to answering question and then giving replies. Do people prefer to listen to and are more patient with a female or male voice? What about one that is jolly versus one that is serious? Another concern is that does the people prepare male or female? Does it have to be jolly or serious? There are several ways that a conversational dialogue can be structured. The most common is a directed dialogue, where the system is in control of the conversation, asking specific questions and requiring specific response, similar to filling in a form. Like this system asks, which city do you want to fly? Caller, London. System, which airport? Gatwick, Heathrow, Luton, Stansted, or City. Caller, Gatwick. System, what day do you want to depart? Caller, Monday next week. System, is that Monday? May 5? Caller, yes. Other systems are more flexible, allowing someone to make more initiative and specify more information in one sentence. Pen, pen-based interfaces enable people to write, draw, select, and move objects on an interface using light sensor stylus that capitalize on the well-honed drawing and writing skills. Smart pens like the Live Scribe Echo 2 uses a combination of an ink pen with a digital camera that digitally records everything written with the pen on special paper. So the key with these interfaces is that it allows you to do the task naturally. Just like this, it capitalizes on our writing skills. So different tasks is has different ways of being natural to us. So the key is being natural. Like for example, the great about the feedback that I received is that it's more natural actually to take notes in this app, which is OneNote, which I just need to do this, like control Windows right and then Windows left, and then that will allow me to actually create a presentation like this easily. So I'm using the right interface that is natural. So this is an example of that. The pen decodes the dot pattern as the pen move across the paper and stores the data temporarily in the pen. The digital pen transferred data that has been stored in the pen. So basically, this interface works like the pen store the information via pattern and then it sends it to the computer via Bluetooth, computer or tablet. Handwritten notes can also be converted and saved as standard type text that can be edited and organized subsequently. So this handwritten, it can be scanned and then you can import this to this notepad and then you can erase that and then write a new one. So it's so useful, right? Another thing about the importance of learning these interfaces is that you're now aware of the possibilities of and the limitations of the current technologies so that when you know the limitation and the possibilities, you will be able to use the right interface at the right task. Another related thing to that is that they said that a man without tools is nothing, but a man with tools is everything. So a man with that learns how to use this interface, especially in computers, in the right task is everything. So it's like he has like a superpower. The digital pen. So here, this is particularly useful for a team who is working together and communicating with each other from different locations. They're also very versatile. For example, the Apple Pencil, when used with the iPad, enables people everywhere. So it also allows this to collaborate better. Remember the collaboration tools such as Teams that has now not just app, it has an ability to screen share, to do these things. So those are multi media or multimodal interfaces application that allows them to collaborate effectively. So this particular tool is useful for collaborating because it's allow different people to manipulate the object. And then brain computer, we will discuss this in the next videos. We'll proceed with the second type, which is the most useful. Uh, I think it has been the most useful and it still is today, but it's quickly, I think, being replaced. It will be replaced by virtual reality or multimodal or interface where you can interact with the interface with your physical, like tactile gestures. So those different are missing in this graphical interface. So let's start. The first is the graphical or GUI in the computer. So here's the first GUI by Microsoft. So here's the first example. So new ways visually designing interface become possible, which include the use of color, typography, and imagery. So aside from command base, another thing is that this interface, this is the first interfaces. The second interface that comes up is like this. It's not this pen and then it's not this voice. So it's just that this voice and pen is categorized as command. And as you're trying to give input via command of type, spoken, and drawing. So this graphical, the original GUI was called Windows Icons Menus Pointer. Windows, section of the screen that can be scrolled, stretched, overlap, open, close, and move using a mouse. So here's the window. I think all of you are familiar with this. So it can be scrolled like this, and then it can be stretched, it can be zoomed in and out. It can be open, it can be closed, it can move using a mouse. Icons, pictograms that represent applications, objects, commands, and tools that are open for activate or activated when clicked on. So the thing about this icons in the GUI is it allows to communicate the long text such as long command base into one icon. So let's say a file, instead of like doing that in a command line with a long words, it could be represented in an icon. So they say that an icon sometimes could be worth 1,000 words, and a word could be worth 1,000 icons, is because for some tasks like deleting 10,000 files, command line or commands or words are better for doing that. However, for some commands like this, like file, it's better for people because it's more natural to see like a folder than to see to put or remember specific type commands. Pointing device, a mouse controlling the cursor as point of entry to the windows, menus, and icons on the screen. So this cursor is the uh, next type of interface that was invented. Menus, list of options that can be scrolled through and selected in the way a menu is used in a restaurant. So that's actually the where the menu come from. It's from the restaurant where it gives you a quick glance on the tasks that you can do on that particular window. Three, developers were largely constrained by the set of widgets available to them, of which the dialog box was prominent. So before, the developers were largely constrained by the widgets, um, which the dialog box like this, it's just a box, a dialog box was prominent at that time. A widget is a standardized display representation of a control, like a button or scroll bar that can be manipulated by the user. So before you were limited by a button like this and then a control. There are now different types of icons and menus, including audio icons and audio menus, 3D animated icons, and even tiny icon-based menus that can fit onto a smart screen. The GUI elements include circulars and inlines that are used to show small snippets of information, date, time, current schedule, notification, etc. So here is an example of this new menus and icons. It Because of the evolvement of LED technology, you can now represent these circulars and inlines that used to show small snippets. The basic building blocks on the desktop and laptop is the window, in which apps, browser, dialog box, interactive forms, feedback, or error message are presented. So, the as you may know, the basic building blocks for laptop, such as this or the one that I'm using, or computer, is Windows. So those it provides a lot of capabilities, but it actually limited in size. That's why developers try to fit those in one window. So they study those to be able to uh, make multiple tasks uh, s- in one window. We will discuss that further here. Window, menu, and icon design. So window design. So how would you design, or how developers have been designing the window that we are using on the screen? Various techniques have been developed to help user locate a particular window. A common one to being to provide a list as part of an app menu. Mac OS also provides a function that shrinks all windows that are open for a given application so they can be seen side by side on the screen. So a common one is to list a part of an app menu. So basically, you provide the different windows in the menu. And also another thing with the window is with Microsoft, the a very useful command or window design feature is the window right bottom and then window left. So it allows you to minimize your screen like that to the right so that you can show the other window to the left. So here, another example on how the technique window. So it's showing a favicon of types top site visited below the search bar. So it allows you to see the top sites you visit. A particular kind of window that is commonly used is the dialog box. Confirmations, error messages, checklists, and forms are presented through dialog boxes. Information in the dialog boxes is often designed to guide user interaction the user with the user following the sequence of options provided. A common problem with this style of interaction is that there is a tendency to cram too much information or data entry fields into one box, making the interface confusing, crowded, and difficult to read. So if you ever encounter a dialog box that provide an error message that tells you what to do next in sequence, you need to click OK and then go to the next sequence to be able to solve the issue. The issue with that is that you need to crowd a lot of information for solving a problem in a few steps of actions. So another problem with window design is the joys of filling in forms online. Huh, because you need to log in and then you need to register and then you need to make your password as secure as possible. So, most of the time you forgot your password. And after you deal with that, you need to input all the payment information, which basically make the website unusable. Having so much inconsistency across online shopping sites can be frustrating. It's easy to overlook or miss a box that needs to be filled in, and after submitting the page, an error message may come back from the system saying it is incomplete. This may require having to enter sensitive information again as it will be removed in the data processing stage. For example, the person credit card and three of four-digit security code. A better design is to have predictive text option where someone needs only to type in the first one or two letters of their country to cause a narrowed down list or choices to appear which or can select within the interface. So a predictive text allow to automatically fill the text for you and a single sign-on. It allows to save your passwords on site so you don't need to type it again. Keyboard shortcuts and taskbar are often used for switching between windows. Another technique is the use of tabs that appear at the top of the web browser that show the name and logo of the web page that have been visited. This mechanism enables people to rapidly scan and switch between the web pages they have visited. Some browsers now often offer a menu of open tabs arranged vertically that can be more easily browsed. So, keyboard shortcuts like Control 1 to go to the first tab, Control 2 to the second tab, has been developed to be able to counteract this window limitation. Another technique is a use of favicon or the name of the app on this screen like this. You're gonna see the name of the tab. And then another technique that has been used is a menu of open tab arranged vertically. So it are arranged vertically that can be more easily browsed, such as in your phone. I know that when you click some button there, it allows you to see the uh, apps that is open, currently open apps in vertically. So yeah, it makes it more natural to be able to see or open tabs. Menu design. The contents of the menus are also, for the large part, invisible, dropping down only when the header is selected or rolled over with the mouse. The various options under each menu are typically ordered from top to bottom in terms of most frequently used options and grouped in terms of their similarity with one another. For example, all formatting commands are placed together. So the key with this menu design is that they are invisible and they are placed in order of usefulness. And also they are also categorized in their similarities with others. But the problem is that it can be difficult to know how to group them, which we're going to discuss later. There are numerous menu interfaces styles including flat, list, drop-down, pop-up, contextual, collapsible, mega, flyout, and expanding ones such as cascading menus. Flat menus are good at displaying a small number of options at the same time or where the size of the display is small, for example on smartphones, cameras, and smartwatches. Expanding menus enable more options to be shown on single screen that is possible with a single flat menu list. In particular, cascading menus require them to move their cursor over the menu item while holding the mouse or touchpad down, and then to move their cursor over to the next menu list when cascading menu appears and select the next desired option. So as you can see guys, there's are a lot of menu techniques that could be applied. So expanding menus are for options to be shown on a single screen that is possible within a single flat menu list. So for a single flat menu list, uh, an expanding menu is the right menu to use. Flat menus are good at displaying a small number of options, and then cascading menus require them to move their cursors over the menu while holding the mouse or touchpad down, and then move the cursor over to the next menu list when cascading menu appears and select the desired destination. Another example of expandable menu is a mega menu in which many options can be displayed at using a 2D drop-down layout like this. Short phrases like bring all to front can be more informative than a single words like front. Operations such as quit and save should also be clearly separated to avoid accidental loss of work. So I know a lot of you accidentally log out because the task that you want to do in your website is along with the log out button. Remember, ring the location of frequently used commands like spelling and replace is often achieved by remembering their spatial location. For infrequently used commands like sorting lists of reference into alphabetical order, users can spend time flicking through the menus to find the command sort. The placement of options in menus can also change between different versions of an application as more functions are added. So the thing here is that these are basically depends on the type of application that are you are using because designers actually use mental model like for this shopping for example a shopping site like this you have a mental model of your like Amazon or Shopee that you use to browse. So you have an expectation on how the website are actually should be designed. So a lot of developers copy that and then just change a little bit because that's a proven model. So for sorting, if you use an expandable, it can be difficult to or collapsible menu. It can be difficult to find that. So based on research, this type, like a 2D or mega menu, is more usable than a collapsible menu where you click the menu and then after that there's another set of menu because it can be hard to know or to locate your it can be hard to locate the task that you are using or the button. Another thing is that based on research, people only stay in a window for 20 seconds. So and also, they don't search for all of this, or they don't look all of that option. They just use Control F to search for the thing that they want. Icon design. The appearance of icons in an interface came about following the Xerox Star project. They were used to represent objects as part of the desktop metaphor, mainly folders, documents, trash cans, inboxes, and outboxes. The assumption behind using icons instead of text labels is that they are easier to learn and remember, especially for non-expert computer users, and they can also be designed to be compact and variably positioned on the screen. So the thing about this icon is that they mimic the exact representation in real life. So the first one was developed by Xerox Star Project. It mimics it from the desktop metaphor, which in a desktop, we have a folders, right? A documents, a trash can, inboxes, and outboxes. So that's how Office desktop used to look. Now they copied that, so that's the reason why the icon that you're seeing on your screen is look like that. Because that's the first principle for designing these icons is that they mimic exactly what the thing are supposed to do. So another reiteration is that an icon could word 1,000 words, and then a word could word 1,000 icons. In this case, icon is better or more applicable for things such as folders, documents, trash cans, etc. They now populate every app. These include depicting tools, for example, Paint 3D, status, such as Wi-Fi strength, categories of apps, for instance, health, personal, finance, and a diversity of abstract operations, including cut, paste, next, accept, and change. They have also gone through many changes in their look and feel, black and white, color, shadowing, photorealistic images, 3D rendering, and animation have all been used. So it has been experimented a lot on what works and what doesn't. But basically, uh, it boils down to what feels more natural on or things that will make sense for the ongoing activity. So categories has been developed as well. Like this, here is an example of the previous version of icons. Here, it tilts to the left and it looks fun to look, while here it's look boring. So that's the previous two version of Apple. So another thing with the design is the metaphor. So it must provide a metaphor or analogy to be able to make sense of this abstract thing that you want to do. Because usually a command base is an abstract, right? It's a long text. So to describe those long text, it needs via icon. It needs to be easily understandable using a natural and everyday use of people, like this printer, keys, uh, camera, etc. So here's another example. So another thing is that this phone has small real estate, so they need to fit or the developers need to fit a lot in small size. That's why it's limited. It's 2D only. It's not 3D. Uh, and For this small, like smartwatch, it only has a few colors like white, black, and then blue. So that's the reason why it's not as colorful. Yeah. So that's the reason why you see those icons look like that is because of the small real estate and also the LED or LED or touchscreen that accommodate these features. Because if you do not know, small screen are harder to design because you have to fit a lot of features in a small hardware. Unlike a larger hardware, they are they can accommodate a larger feature because they are large. But it also compromises the portability because you can bring that anywhere. Many operations in an interface, however, are actions to be performed on objects, making it more difficult to represent them using direct mapping. Instead, a well-known technique is to use a combination of objects and symbols that capture the salient part of an action by using analogy, association, or convention. For example, using a picture of a pair of scissors to represent cut in a word processing application provides a sufficient clue as long as the person understands the convention of cut for deleting text. So there's a lot of psychology as well uh, in the background of designing these icons because sometimes you can combine multiple objects like scissors or a combination of scissors, and you have to know if that feels natural to the user. So the only way to know that is by doing a research. There are many icon libraries available that developers download for free. For instance, the nounproject.com or fontawesome.com. So there's a lot of icons. Free icons that you can use on your application. Various online tutorials and books on how to design icons are also available, together with sets of proprietary guidelines and style guides. Among the various guidelines, it suggests that different categories of application, for example, business, utilities, entertainment, and so on, should be represented by a different genre, and it recommends displaying a tool to communicate the nature of a task, such as magnifying glass for searching or a camera for photo editing tool. Android and Microsoft also provide extensive guide and step-by-step procedures on how to design icons for its applications on its website. So the great thing about here is that this corporation, Microsoft Apple, has a guidelines already that you need to follow that will allow you to design your icons to be usable. Another thing is that they also have integrated software that allows you to easily create an app with them. So it's all in one place. It's like a multimodal interface, which we will discuss later. Web, early websites. So this is a part of the graphical user interface as well. We're dealing with GUI because a lot of things are also like what I've said. This is still the most useful today, a graphical user interface, because it feels natural compared to other interface. Early websites were largely text-based, providing hyperlinks to different places or pages of text, and much of the design effort was concerned with information architecture, that is, how best to structure information at the interface level to enable users to navigate and access it easily and quickly. For example, Jacob Nielsen adopted his and wrote usability guidelines to make them applicable to website design, focusing on simplicity, feedback, speed, legibility, and ease of use. Since then, the goal of website design has been to develop sites that are not usable but also aesthetically pleasing. So the early websites are largely text-based. So because we start with the command-based, right? First, it was text-based, and then the design effort was concerned with the information architecture. So how would you structure the information? So usually you structure or you move to a website from top to bottom in order of usefulness, like menu. So that's how they structure this. And also, it's not just about the usability. So, like the function or task must be could be useful, but how does it feel? What does emotion it triggers? So now it also, you may find websites that still does not follow that principle, but developers are actually increasing to worry about that since 2000, since yeah, year 2000. Steve Krug argues that many website design create sites as if the visitor was going to pour over each page, like what I've said earlier. Reading the finely crafted text word of word, looking at your use of image, colors, icons, and so forth, examining how the various items shape have been or organized on the site, and then contemplating their options before they finally select link. People, however, often behave quite differently. They will glance at a new page, scan part of it, and click the first link that catches their interest or looks like it might lead them to what they want. So they don't actually check all the details on the website. So they just check the things that might provide them the uh, thing that they want. So another important concept here is the cognitive load. Make sure that the user would not have a lot of load to find the task that you want them to do in their website because they will just stay away because people are usually distracted today. So we need to make it easier for them. Another interface element is an integral part of any website is breadcrumb navigation. Breadcrumbs or category labels appear on a web page that enables visitors to peruse other pages without losing track of where they have come from. The term comes from the wayfinding technique that Hansel used in the brothers Grimm fairy tale Hansel and Gretel. This metaphor conjures the idea of leaving a path to follow back. Breadcrumbs are also used by search engine optimization tools that match up a user's search term with relevant web pages using the breadcrumbs. So the related topic with here is the undo in Microsoft Word. I know you know that. And the back option in Chrome where it allows you to go back. So website also offer that allows you to check where category you came from, like this product information smart lights. Because that's actually part of the usability guidance that developer use to create their website. Key considerations: all websites are captured by three questions proposed by Keith that are still integral to web design. Where am I on the website? What's here? And where can I go? So again, repeat it after me. Where am I? What's here? Where can I go? So look at website like Nike here. So the thing here is that Nike is not designed to do that because if you click something there, it will route you to a video or uh, things that will advertise that will allow you to experience how famous people use their shoes because it's not designed to be able to you to do what you want to do. They want you to kind of like manipulate or experience the shoes with the famous or branded people. So next is mobile. For example, they are now commonly used in restaurants to take orders, at car rental agencies to check in car returns, in supermarkets for checking stock, and on the street, multiplayer gaming. Smartphones and smartwatches have an assortment of sensors embedded in them, such as accelerometer to detect movement, a thermometer to measure temperature, and galvanic skin response to measure changes in sweat level on one skin. Other apps may be designed for fun. An example of an early app developed by magician Steve simply for a moment of pleasure is ideal. So here, when you tilt that, it will produce a sound like you're drinking a beer. So another thing is that we're using this every day in restaurant for scanning payment. Uh, so for scheduling um, uh, a car rental and checkings of etc. Right. So here is an example of one of our innovations. So here's an app that will track your purchase and will tell you if the purchase you made will help the environment. So for those concerned in global warming, smartwatches such as those made by Google, Apple, and Samsung provide multitude of functions, including fitness tracking, streaming music, text, emails, and latest tweets. They're also context and location aware, for example, on detecting person presence, promotional offers may be pinged at them from nearby stores, tempting them into buy. How do you feel about this? Do you think it is the same or worse compared to the way advertisements appear on a user's smartphone? Is this the kind of context-based advertising ethical? Another key challenges with this is that since this have been part of our everyday task, kind of like an extension of our abilities, right? Or like actually, it's actually I believe it's part of our body already since it's extend our abilities like our hands and feet. So it can use against us, the advertisement that pops up. It can be useful if it's a discount for a restaurant, but if it's like distracting us from like exercising or doing things that will benefit our health or benefit us financially, then it may not be uh, ethical. Mobile interfaces typically have small screen and limited control space. Designers have to think about what type of dedicated hardware controls to include, where to place them on the device, and then how to map them to the software. Apps designed for mobile interfaces need to take into account the ability to navigate through content when using a mobile display is constrained, whether using touch, pen, or keypad input. The use of infinite scrolling provides a rapid way of scanning through digital content. So for mobile apps, for website we have Control F. In mobile apps we have infinite scrolling, where website or apps are designed for us to just scroll. Since the actions are limited to us using touch, swipe, pinch, or tap, those are the limited action that we can do. So, like what I've said earlier, small gadgets are more difficult to create because you have to integrate a lot of features in a small and portable way. The average fingertip is between 1 and 2 centimeters wide, so target area should be at least 7 millimeter to 10 millimeters so they can be accurately tapped with the fingertip. A number of other guidelines exist providing advice on how to design interfaces for mobile device. An example is avoiding clutter by prioritizing one primary action per screen. So the thing here is that uh, mobile apps are designed to prioritize one action per screen. So read that again, one primary action per screen. And then the fingertip is between 1 to 2 centimeters. So each task that you see there should be at least 7 millimeter to 10 millimeter. So that's how designers do that. So let's move on to appliances. What they have in common is that most people using them will be trying to get something specific done in a short period of time, such as starting a wash, watching a program, buying a ticket, or making a drink. They are unlikely to be interested in spending time exploring the interface or looking through a manual to see how to use appliances. Many of them have LED displays that provide multifunctions and feedbacks about process such as temperature, minutes remaining, and so on. So the thing here is that these appliances are designed to do a thing in a short period of time, whether toasting or whether uh, boiling water in thermos. But the problem here is that the feature of usability, such as this LED new technology, could add up to the complexity that may not be better in terms of cost for the user because uh, some this LED, since they need to integrate it in a small hardware, and since it's portable, they're also easy to break. So the more complex, it's also easier to break, especially for simple tasks like that. For example, a microwave. So a digital microwave lasts for approximately 1 to 2 years, while non-digital could last you a lifetime. So you have to think the pros and cons. Sometimes it may not be useful to convert to better features. Here, the two fundamental design principles of simplicity and advice visibility are paramount. Status information such as what photocopier is doing, what ticket machine is doing, and how much longer the wash is going to take should be provided in a simple form and a prominent place on the interface. A key design question is as soft displays increasingly become part of an appliance interface, for example, LCD and touchscreens. What are the trade-offs with replacing the traditional physical controls, such as dials, buttons, and knobs, with these soft display controls? Designing the controls to appear on an LCD screen would enable more information and options to be provided. For example, toast only one slice, keep toast warm, or automatically pop up when the toast is burning. It would also allow precise timing of the toasting in minutes and seconds. However, it's likely to increase the complexity of what previously was set of logical and very simple actions. So before it's very simple, now it could be more complicated once you add feature that may not be the thing that you want in the first place. Touchscreens. Single touchscreens used in walk-up kiosks such as ticket machines or museum guides. ATMs and cash registers, for instance, restaurants have been around for a while. Multi-touch surfaces, on the other hand, support a much wider range of more dynamic fingertips options, such as swiping, flicking, pinching, pushing, and tapping. They do this by registering touches at multiple locations using a grid. These multi-touch methods enable devices such as smartphones and tabletops. So we will continue the discussion with this touchscreen. No, actually, let's finish it until that. Yeah. So we'll continue with touchless virtual reality and then multimedia later. So single touchscreens used in walk-up kiosks such as ticket machine. Basically, these are multi-touch surfaces on the other hand that support a wide range and more dynamic fingertip option. Swiping, flicking, pinching. So they use a grid to do that. They register grid at multiple locations. So this is how the software do this. This is how it's possible to do this in your tablet. This multi-touch method enables devices such as smartphone and tabletops to recognize and respond to more than one touch at the same time, supporting a variety of actions, such as zooming in and out of maps, moving photos, selecting letters from a virtual keyboard when writing, and scrolling through lists. Two hands can also be used together to stretch and move objects on a tabletop surface, similar to how both hands are used to stretch an elastic band or scoop together a set of objects. So you can use the two hands as well to stretch, zoom in, zoom out the object. Alternative conceptual models have been developed to carry out these actions at the interface, such as the use of cards, carousels, infinite scrolling, which help users to move quickly. Predictive text can also be used to help people type faster. Both hands may be used on multi-touch tabletops to enable people to make digital objects larger and smaller to rotate them. Dwelling touches, pressing and holding finger down can also be used to enable someone to perform dragging actions and to bring pop-up menus. One or more fingers can also be used together with a draw action to provide a wide range of gestures. However, these can be quite arbitrary, requiring someone to learn them rather than being intuitive. So, three fingers, I know you rarely use that in your smartphone, but it can also be used, but it may not be intuitive. That's why we rarely use three fingers, even two fingers. We only use one. So as much most useful functions or tasks are being done using one finger. So another related to this is that so that's how you represent gestures on that interface using one um, finger, two finger, three finger. Here, you actually don't need to touch the computer. You just need to provide a gesture like this. This is a kinetic technology developed by Microsoft. So gesture, which is in the touchless part, involve moving arms and hands to communicate. For instance, waving to say goodbye or raising an arm to speak in class or to provide information to someone, for example, holding two hands apart to show the size of something. There has been much interest in how technology can be used to capture and recognize a person's gestures input by tracking them using cameras and then analyzing them using machine learning algorithms. They found that gestures need to be sequenced to be understood in the way a sentence is composed of a noun, then verbs, the object plus operations. For example, for speaker on, they use gesture on one hand to designate the noun and another on the other hand to designate the verb. So basically, for this gesture to work, they found that you doing it like a sentence, like there's a noun and verb, so there's a sequence on how to use this, is more effective on creating an application. So, for example, to lower down a volume, you pinch this like in a pinch your two fingers counterclockwise, and then for increasing the volume, it's clockwise. And then for like there's an app that was created for concert. So to increase the volume there, you need to point the interface and then point upward the left hand. Point the right hand point to the interface and the left hand point up. So here, Microsoft Kinect technology, which recognizes a range of gestures that surgeons use to interact with and manipulate MRI or CT images, including single-handed gestures for moving forward, so single hand to move forward the interface and backward through image, and two-handed gestures for zooming in and panning. So two-hand is for zooming and panning. So you might wonder, why does the surgeon needs that? Because for surgeons need to look for zero for scanning, and they also need to check a lot of computer interface base while they're doing the surgery. But unfortunately, they don't have time to remove their gloves during the surgery, so Microsoft developed it. Several car dashboards have a form of gesture control. For example, BMW's iDrives enable drivers to control certain functions such as turning up or down the volume with the use of hand gesture by a 3D camera. So, like what I've said earlier, for two fingers clockwise, for volume up, and then counter up clockwise for volume down. A key design concern for using gestural input is to consider how computer system recognizes and delineates a person's gestures. In particular, how does it determine the start and end points of a hand of arm movement, and how does it know the difference between diptic gesture, a deliberate pointing movement, and hand waving, an unconscious gesticulation that is used to emphasize what is being said verbally. So the key challenge here is that How would the touchless gesture interface would determine if it's intentionally or unintentionally. Another thing is there's an app that was not does not need an interface, specialized interface like this Insurgent to use a gesture base. They just need your laptop webcam, and then the software will do itself. You see, that's the limitation or the capabilities of this interface technology that I want you guys to know that it's actually possible to do that. So you can use that interface on your um, task to be able to do that more effectively. Virtual reality. So image are displayed. So like what I've said in the previous videos about collaboration tools, where virt- uh, people or companies are increasingly investing in virtual realities because it could feel more natural than these GUI interfaces. This is what the interface that could be a multi-modal interface that would allow us to be more productive in the future. So this is a technology um, to keep watching. Images are displayed stereoscopically to the users, most commonly through VR headsets, and objects within the field of vision can be interacted with via an input device like joystick. The 3D graphics can be projected onto Cave automatic virtual environment floor and wall surfaces, desktops, 3D, TV headset, or large shared displays. For instance, IMAX screens, besides looking at and navigating through a 360-degree visual landscape, auditory and haptic feedback can be added to make experience feel even more immersive. So a haptic and auditory, haptic we will discuss that is like a touch sense. So physical, like you physically feel the virtual environment. So there's many ways. So you may think that the way to use or to do this virtual reality is to VR headset. Right now, there's a lot of ways to project it. Presence in this case means a state of consciousness, the psychological sense of being in the virtual environment where someone behaves in a similar way to how they would if at an equivalent real event. The illusion afforded by the technology can make visual objects appear to be lifelike and behave according to the laws of physics. So another thing is that it actually mimicking the real world, which follow the laws of physics. Another distinguishing reality feature of VR is the different viewpoints it can offer. Players can have a person perspective where you when you're looking at something, it's a first person perspective uh, in the game environment through their own eyes, or a third person perspective where they see the world through an avatar. So something that move up like this, they see you see yourself like that in a picture, like you see that's a third person perspective, and then it visually represented on the screen. An example of first-person perspective is that in first-person shooter games such as Doom. So here's a first-person perspective where player moves through the environment without seeing a representation of themselves. What? Since then, VR technology has come of age and improved greatly with new techniques being developed that seek to reduce motion sickness. So one of the challenge in VR is the motion sickness, where it could be difficult if you use it for some time. Um, so they are trying to solve that now. There are now many off-the-shelf VR headsets, for example, Meta Quest 2, HTC Vive, and Sony PlayStation VR that are affordable and comfortable. They also have more accurate head tracking that allow developers to create more compelling games, movies, and virtual environment. So we will discuss augmented reality in the next videos. Physical, for now we won't be able to discuss this. Now we'll move on multimodal type of interfaces, which is the multimedia, last one. So we discuss everything because it will be it will it will break our momentum if we stop, so we will just finish it. Multimedia, as the name implies, combines different media in a single interface, namely graphics, text, video, sound, and animation, and links themselves together with various forms of interactivity. Clicking a link in an image or text triggers another media element such as animation or a video. The assumption is that combination of media and interactivity can provide better ways of presenting information than can a single media, for example, just a text or video alone. So the thought process about this is in education, where it's currently being targeted, where people would learn better if there's a lot of interface. So you might think that in video, there is a lot of media already, like you can input text, but actually that could be a different as well, like a video and a text, right? In a website, for example, so or in an app. So you can have video, graphics, text, image, all in one. So that's why it's a multimedia interface. So here's an example of multimedia learning app designate for tablets, where it shows you the road. Uh, and multimedia has largely been developed for training, educational, and entertainment purposes. However, it was also found that there's a tendency to click videos and animations rather than reading the text. Despite this, a recent reviews reported how multimedia is still an integral part of teaching practice. A variety of multimedia tools, both standalone and web-based, are still commonly used. So standalone is an app, or a web-based is like you can access it on a website. So those are being used as well. So standalone does not need to be accessed through web. It could be your company application, despite their downside of a tendency to click of different media instead of reading a long text. Another key thing is that different interface are good for different purpose. For example, a movie to depict an action, a text to depict details. So that's why reading is the most effective part of learning, is because it provides the details. Um, Audio for stimulating effect, and let's see. Students consistently admitted to ignoring the text on the interface in search of clickable icons of the author, which, when selected, would present an animated video of him explaining some aspect of the design. There is a danger that multimedia environments may in fact promote fragmented interactions where only part of the media is ever viewed. So it doesn't provide you details, so you have a fragmented view of how the system actually works in details. Specific examples include electronic notebooks that are integrated as part of the interface, where students can type in their own material, multiple choices quizzes that provides feedback about how well they have done, interactive puzzles where they have to select and position different pieces in the right combination, and simulation type games where they have to follow a set of procedures to achieve some goal for given scenarios. Another approach is to employ dynalinking, where information depicted in one window explicitly changes in relation to what happens in another. This can help people keep track of multiple representation and see the relationships between them. So to counteract the fragmented view that this multimedia interface provides, so which is counterintuitive, you may think that multimedia interface would provide different interfaces, but actually you need to do some work to overcome its challenges, which is the distraction, right? So here, um, so they have to fill up the form or answer multiple choice quizzes that provide feedback. So it's like in a training, right? You would have a question to be able to really understand what you have discussed. or puzzles where you have to select a position in different places. So that's another technique. And then simulation type games where they have to follow a set of procedure to achieve some goal. So another thing is people gamify their multimedia interface to be able to make it the learning uh, active. Another approach is dynalinking, where it depicted information in one window and it changes in relations to what happened in another. Because another thing about this is that again, this is just an interfaces. It's not really a real world case where you see the full picture in their view or how the system view. That's where reading is the most important. Most important pieces of learning is because it provides you a detailed and a complete view of the information. Now, we have discussed a lot, basically about the four types of interfaces: command interfaces, graphical interfaces. We haven't discussed the physical interface or sensory, and then we have discussed multimodal or the emerging interfaces. Another thing is that this multimedia interface or multimodal interfaces also have some of the command interface such as voice. It could also have the brain computer shape changing, which is part of the GUI. So it has a different uh, interfaces that came from the first parts. But yeah, another thing is that in this next videos, we will discuss this multimodal, which it's kind of like a multimedia interface, but it allows a gesture as well. So it's not just in a tablet; it allows you to gestures. It also allows you to communicate via voice, speech, and then to visual. So yeah, it's more advanced type of multimedia interfaces. And again, guys, thank you for watching, and I hope you like this long form video, which provide the detailed overview of one of the most useful concept in computer science today. Again, thank you for watching, and see you on the next video. Peace.